Hey everybody. Today we're going to continue our talk about one-step equations, and we're going to take a look at a new property that's going to help us solve different types of equations than we've seen before. And that property is the multiplication property of equality. It tells us that multiplying each side of an expression by the same non-zero number produces an equivalent expression. So this is very similar to the addition property of equality, the subtraction property of equality, and the division property of equality. Remember, all of these properties basically say that if we do the same thing to both sides of the equation stays equivalent. It produces an equivalent equation. So we can use this property to solve equations like this. X over A equals B, right? And remember, A cannot be 0 because we can't do X divided by 0. And if we're trying to solve for X here, what we can do is use the multiplication property of equality to multiply both sides by A. Since we have division right here, right, that little line means division, we're going to use the inverse operation, which is multiplication. The inverse operations cancel out. We're left with X equals B times A. So let's see what that looks like when we have an example with actual numbers. All right, here we have 4 examples. Our first one is x over 2, or x divided by 2, equals 0.75. So since I see that we have division here, right, x divided by 2, I'm going to use the inverse operation, which is multiplication. So I'm going to multiply both sides by 2. 2 times the fraction over here, and I'm going to multiply by 2 over here. Now, because these are inverse operations, they cancel. I'm left with x equals 0.75 times 2 is 1.5. Okay? Our second example, c divided by 3 equals 13. We're going to do the same thing. This is divided by 3. Inverse operation is multiplication. We multiply, we cancel, we have c equals 39. C equals 39, that's our solution. Down here, now don't get tricked just because our variable is on the right side. We still look at this that says d divided by 5, inverse operation is times. Times 5 over here, 5 times negative 3.4, that gives us 17. D equals negative 17, I should say. Positive times a negative. Now, our last example, y divided by negative 4, same thing, inverse operation times negative 4. Times negative 4, y equals negative 12. Okay? All right, here are some trickier examples that we have. Our first equation, we have 2/3 x, 2 over 3 times x equals negative 4. Now, we can think about this problem in 2 different ways. 2 over 3 times x. Since this is multiplication, we would normally want to divide here, right? Use the inverse operation. We would divide both sides by 2 over 3. Divide by 2 over 3, right? But dividing by a fraction is the same as multiplying by its reciprocal, right? So we can actually think about this problem. If we have 2 over 3x equals negative 4, we can think about this problem as instead of dividing by 2 over 3, we can multiply by 3 over 2 times 3 over 2, right? Multiplying fractions is much easier than dividing fractions. Now, if I look here and I multiply these fractions over here, 3 times 2 is 6, and 2 times 3 is 6. So we get 6 over 6, which just equals 1. So these fractions cancel out, and we're left with 1x, which is what we want, right? We want to get x by itself, 1x. Now, over here, I'm going to make that negative 4 over 1 for my multiplication purposes. Negative 4 times 3 is negative 12. 1 times 2 is 2. So I have negative 12 over 2. And I know 2 goes into negative 12 evenly. Negative 12 divided by 2 is negative 6. So my solution to my equation, 2 over 3 times x equals negative 4, my solution is negative 6. In our second example here, we're going to do the exact same thing. We could think of it as dividing by 4/5 on both sides, or we could multiply by 5 over 4 times 5 over 4. Remember, if we do something to one side, we got to do the same thing to the other side. Now, 5 times 4 going across, that's 20. 4 times 5 on the bottom gives us 20. 20 over 20 is 1. Those cancel. We're left with 1r equals, you can think of that as 1 over 1. 1 times 5 is 5. 1 times 4 is 4. R equals 5 over 4. That's the solution to that equation. Down here now, we have negative 2 equals 2/5 times t. We're going to do this problem the same way. Times 5 over 2 on this side times 5 over 2 over here. Now, 2 over 5 times 5 over 2, I can think about this, right, using the commutative property of multiplication. We'll rearrange those. 2 times 5 is 10. 5 times 2 is 10. 10 over 10 is 1. We're left with t. And over here, we have 5 times negative 2 on the top. That's negative 10. 2 times 1 is 2. Negative 10 over 2. And I know I can simplify that. Negative 10 divided by 2 is negative 5. And our last example here, same thing. Negative 10 equals negative 1/2 times p. We can multiply. Now, this is negative 1/2. I need to multiply by negative 2 over 1 times negative 2 over 1. On the right side, I can rearrange these. Negative 1 over 2 times negative 2 over 1 times p. I'm just going to rewrite this one. Right? Now, on the right side over here, negative 1 times negative 2, that's 2. 2 times 1 is 2. 2 over 2 is 1. These cancel out. P equals 1p equals, make that negative 10 over 1. Negative 2 times negative 10 is positive 20. 1 times 1 is 1. So p equals 20. That's the value of p that makes the equation true.